Hello, my name's Luca, and you're watching Computing Tutorials. Today I'm going to be teaching you about hash reversal, also known as hash cracking, using Python. Specifically, we'll be using Python 3.7. I'm using what's called Spider. It's a Python development environment. It's completely fine to be using idle for this as well, which is the general Python development environment that it'll come installed with. There are basically no differences in how the code was actually made and will run, so that's perfectly fine. You don't have to worry about that. Also, we'll be using two Python modules that should come by default installed with Python. The first of which is hashlib, so you just need to type this here, and itertools as well. So hashlib is a library that allows us to hash values and get the digests for them, and itertools is a library that gives us a bunch of different functions that we can use for iteration on iterables, surprisingly enough. Also, for this tutorial, you need to have a general understanding of what hashing is. I'll have a video about that eventually. If you don't know, I'll have some resources in the description though that you can take a look and you can check before you watch this video. So to start off, we're going to want to define some functions. Now I'm going to hashtag these out just so I don't get error messages while I'm writing it. They just annoy me a little, especially these ones as well. They're just there to show that I haven't actually used the module yet, so there's, at this point in time, no reason to have it imported. It's just what happens when you do things prematurely. So we're going to have define brute force here. So we're going to be using a brute force method to crack these hashes. That is just one of many you can use. There are other attacks such as rainbow attacks or dictionary attacks, but this is a great way to teach about iteration, also a good way to get an understanding of how hashes are cracked in the first place. So what a brute force attack does is it will take every single value in a given range and it will test all of them. So if we say no that our passwords could be between 8 and 20 characters, and they have to use lowercase, uppercase, and a number, we have a range of characters, and we have a range of lengths, and we can test each and every one until we find what we want. So also here, what we're going to want to have is our actual call of it, and we're going to want to start adding a couple of parameters to this brute force module. So we're going to need to have the characters up here, and later on we'll be passing the file from it. We won't be doing that now. But we're also going to need the minimum length, and we're also going to need the maximum length. Now we can't actually use the terms min and max in Python, so we need to use minimum, and we need to use maximum. That's because min and max are already things assigned to Python, so you can use them as a mathematical feature. And also, just to get rid of the error message for a second, I'm just going to put print there. So under brute force, we're going to have characters, which I'm going to assign in a minute. And I'm going to put 1 and 3. The reason I'm using 1 and 3 is because I already have a file with two SHA-256 hashes in it. One of them is a hash of ABC and the other one is a hash of DEF. So I already know the ranges I want to be testing. I'll also be testing lengths of 1 and 2 just to show a better way of creating your brute force module than just testing one length. So up here we're going to have characters, and I also know that I'm only using lowercase characters, so again I'll only be creating this with lowercase characters. Realistically, a brute force attack can be quite lengthy, again because you are testing every single thing. So one of the reasons I'm only using a small range of characters and a small range of lengths is purely just because I'm doing a tutorial and we don't want to have it brute forcing and taking ages. So up here now, what we need to do is we need to take our characters and we're going to need to create every possible permutation within our range. So a permutation is essentially just a combination of items. So when it's the length of 1, it would just be each letter on its own, but when it's a length of 2, it would be AA, AB, AC, all the way through to ZZ. So it essentially checks each and every single one, and this is where our little itertools module comes in. So we can just simply type for I, and again I is a variable, you can use whatever you want in place of this. I use I as the name, it's just simple and it's easy to remember. Then we type in range, and we want to iterate for our minimum and our maximum range, but we want to add 1 to our maximum, and this is because a for loop starts by setting this value to the first part of range, and then at the end, like each time the loop runs, it'll add 1 to this, or whatever our step is. We haven't set a step though, and the moment this value, this I, equals whatever value is in the stop part of the range function, that's when the loop will shut. but we don't want it to shut when I equals 3, we want it to shut when I equals 4, because if it shuts when I equals 3, it will actually skip the permutations with a length of 3. So now we just add our colon, and then the next line we want to type forward in itertools.product. So again, .product is just creating the permutations. Brackets here. So the first argument we want to pass this is characters, and the second one is our repeat. So all the repeat is the amount of times in a row the characters can appear. So we just put I there. So this means that instead of having a static repeat, we have a dynamic repeat, and we're iterating through the range of repeats we want, and for each one we're going to be creating the permutations for it. So again, this just makes the program more dynamic. If realistically you were trying to brute force and you knew the hashes were all 3 characters, you wouldn't do it like that, or you could set your minimum and your maximum to 3. So either way, this is just a better way of creating the program. So now that we've got our word here, we just want to test this. We want to see how it comes out. So we'll just type print word, and we'll find out something interesting about itertools.product by doing this. So as you can see, what we've actually received here, they might look a little bit like lists. If you're new to Python, these are actually tuples, and we can tell this by the brackets used on them. Essentially, all that means is that they're immutable, so we can't change what's inside a tuple. So what we need to do is called tuple unpacking. This is where we take the contents of the tuple and essentially just take them out to something else. So we'll be using this, we'll be doing this by using apostrophe dot join our little word here, and now if you run this again, you'll see that we've created a set of strings for each permutation we need. So if we take this out, we can then pass this over to the crack function, which we're about to sort out. But what I'm going to do is I'm going to assign this to a variable, so I'm going to just call my variable plain text. Like that. Invalid syntax. Try it with... Oh, sorry, the invalid syntax is because of the bracket at the end. Sorry, it's my Rust showing a little bit there. Get rid of that. So now, for this crack module here, what we're going to want is we're going to need our plain text, and we're also going to need a file. So, plain text. Now, I know the name of my file, but another way of doing this would just be having an input somewhere that asks the user to give the name of a file. But because I know my input, I'm just going to set that to the default value. So, all the default value is in a function is if nothing is passed through to it, it will take that as the value. So if I don't pass the argument file, it will just set that to a default value, which is going to be hashfile.txt, which is where my hashes are stored, and they're stored in the same directory, so I don't have to put anything else there. So we then press enter on this, and now we want to start cracking them. So because hashes are one-way functions, what we need to know is if a plain text when hashed equals the hash we're trying to crack. If that is true, then we know that we have the plain text of the hash, because when you hash it, it's the same, and if the hash function is truly secure, then it won't have any collisions. Now, hash functions like MD5 are known to have collisions. They still have uses as hash functions though, but if you're storing passwords, this is a bit more orientated towards cracking password hashes, then you shouldn't be using algorithms like MD5, and it is possible to get semi-false positives, because even if there is a collision, regardless, you can still enter that value, and if it comes up with the same hash, then yes, you technically have that user's password, even if the plain text is different. So now what we want to do is we want to iterate here, and we want to open our file, so we're going to use with open. This is like file.open, but instead the with part means that when the indentation returns to where with is, so this tab line here, it'll close the file itself, so you don't need to actually write any extra code for it to do that for you. So inside of this, we just want to have our file, so file, and then here what we want to do is we want to set our mode, which is going to be read, and at the end we want to add a little as statement. So I'm going to say as hashes, and all that does is essentially create a variable name for our file. So now what we want to do is we want to have for line in hashes, and what we want to do here is we want to have a comparison statement. So we want if plain text, but that might not be right just yet, so I'll explain in a minute, equals line. Now what we haven't done here is we haven't actually hashed our plain text, which hopefully you noticed. So now what we need to do is use our hashlib function. So we're going to create a variable. I'm going to call it hasher. Again, you can call it anything you want. Hasher is just the name I was taught to use. Equals hashlib dot, and now after this dot you just need to input the name of the hashing algorithm you're using. I know my hash is a SHA-256. If you don't know what hashing algorithm a hash is stored in, what you can do is you can calculate the length of it. So you can just look up string length calculator, put the hash in, and then you can actually do a little bit of math. If it's in hexadecimal, all you need to do is times the length by 4, and then you know how many bits the digest is in, and with that length you can look up a hashing method that has a digest of the same bit length, and from there you can make assumptions or test if they're the same. So now what you can do is we need to actually hash our plain text. So what we want to do is we want hasher.update, and now we want to put plain text. Now this isn't going to work because what we need to do is encode this plain text value. So we want dot encode, and here we just want to type in a little string UTF-8, and that'll essentially just encode it as a Unicode. It's just a bit of a quirk of the function. There's no need for too much of a deep explanation on that. And then simply here what we want is we want to create what's called a message digest, or sorry, a hash digest. We'll actually do this down here. So what we want is hasher.hexdigest, and all it does is create the hexadecimal digest, or the hash value. Then we just put our little brackets here. And now we want that to equal line, but there's one other thing I need to cover, and that's how our file is actually going to work. So as I'm sure you know, when you have a file like this, you need to have something separating each hash, and even if you just press enter, it might be invisible, but there's actually going to be a new line value. So if I just printed all the lines in my file, it would actually have the new line at the end of whatever the first line was, and it wouldn't have one at the end of the last line. So to deal with this, we can type .rstrip, and just here we can type in the new line character, which is \n, and that will remove that. And now all we need to do is give the user some feedback as to whether or not we know a hash has been dealt with. Just check this as well. Plaintext is assigned to but never used. Again, that's just a bit of an IDE quirk, especially Microsoft Visual Studio likes to do this. And all it does is it basically just gives you little hints and tips if you're doing things that are unnecessary. Especially common in Microsoft Visual Studio, because they even go as far as to tell you that your naming conventions are wrong, which can be pretty annoying. But it's also a good bit of tips if you're trying to stick to more common programming practice. And here we just want to have our line dot rstrip /n. Sorry, forget that it creates 2 for me. That there, and then we just want one more, and there we go. So now we just need to call the crack module here. So crack plain text, and like I said, because we have a default value here, we don't actually need to pass over a file. And now we can run this, and there you go. Sorry, I just realized I had a bit of poor English there. Run it one more time so it looks a bit cleaner. There you go. And also, silly me, didn't put the little plain text here, so. And run that one last time. There you go. So ABC is the plain text for this hash, and DEF is the plain text for that hash. So that's simply how you do hash reversal in Python. The general idea is that you need to have a hash and a plain text stored. I like to use this hasher function all in one function, because the moment this is done, it goes out of memory and we go back to our brute force function here. You can actually confirm that using a trace table, or just by looking at the fact that the call is here, so when this call is run, that collapses. Now, something that's important to talk about, and something you need to be careful about when you're hash cracking, is your memory usage. So computers, when they run programs, will load the instructions, so it'll convert it down to machine code, and it'll load that all into RAM. And RAM is very small and very finite. For example, my laptop here only has 8 GB of RAM. The average computer these days usually runs between 8 and 16. Sometimes you'll see 32 or 64, or at a push more than that. You don't really need more than 16 GB, but you can see that. And when you're actually loading in these values here, the reason I do it this way, and I call this function here, is to make sure I don't store anything else. So this for loop is to turn each permutation temporary, because if we stored every permutation, we'd be storing an absolutely ridiculous amount of data. Let's say that this was going just between 8 characters and 8 characters, right? Well, we already know that we have the letters of the alphabet. We already know that we need to eat 8 bits to store each one of them. So that's already going to be 8 times what, 26. And then you're going to want to times that again by 8. And the fact that would be to the power of 8 as well. And that would be the total amount of memory you're using it. And very quickly, brute force operations can be very inefficient and take up a lot of memory. When you do it this way, we get rid of the space complexity. We don't use much memory in our computer, but we keep the time complexity, which is the downgrade of a brute force attack, is that it will take a long time if you test each and every value. Obviously, my example here doesn't look like that because we've used such a small range, but we can actually test that just by saying we use a range of, say, 8 to 12. And if we start running this, well, by the time I do an outro for the video, you won't actually see the little in5 signaling that that's finished. So, I hope you've all learned something today. If you have, give it a like, give it a comment. If you got stuck, make sure to pause, rewind, ask a question, search a keyword that you heard that you may be not understanding. If you need any sort of help, just let me know, I'll do what I can. Thanks for watching, have a nice day.